So I'm Tim Bannister. I'm from the Scale Factory. I'm talking about how many Kubernetes clusters do you need? I'm going to ask many questions of the audience, but I'll start with one. Who's heard of the Scale Factory? Okay, not many people. So you get the explanation. You know, that's the prize for not putting all your hands up. We are a firm that does consulting mainly for business-to-business software as a service firms. That's our target market. We work a lot with AWS. We work with Kubernetes, if you use Kubernetes, but we also work with serverless functions, if that's your thing, or we'll help you get like ISO certified or whatever. That's what we do. I'm one of the staff there. I'm a senior lead consultant. I have to remember the job title. And that's enough about the company. Let me talk about the talk. So there's different things that you might think as like driving why you choose a particular number of clusters. And I'm going to start with the first one, cost. So we sometimes get, not very often, we sometimes get someone who wants to book some consulting, and they say, right, we've got a question. And we've got a question like, how many clusters do you need? And what we'll say is, okay, well, we think, based on what you've told us, that's like, we'll have to do like a few hours of workshopping, maybe like 7 hours of workshop. Let's plan that out. And just sometimes, and this doesn't happen very often, people say, oh, no, I just want the answer. Can we just pay you to give us the answer without us telling you about our business context? And we can't. That's not how our kind of consulting works. We have to find out about what you need. And if you needed cost as your thing, well, I would say the answer is one cluster. That's your starting point. Because if you put it all in one cluster, then you've got the lowest fixed overhead. You've got one control plane. You've got the lowest overhead for the work you do to upgrade it. We'll come to some of the snags around that, but one cluster is the option to go for if you are literally driven by cost and everything else is secondary. You know, so if I click the right button, it looks a bit like this. Lots of pods, one cluster to run them all. You save cost by having just one control plane, and you save effort on managing that cluster because you've only got one of them. You can still split it up. I hope, because this is a Kubernetes conference, that you've heard of namespaces. I'm not going to go into what namespaces are, but you can split up that one cluster, and you can still provide isolation. You've got the mechanisms that people have. It's a common pattern. So you take one cluster, and you divide it up, and you can say, OK, I'm going to put my production stuff in a production namespace, and I'm going to deploy the same app in some other namespaces. You've heard this story before. So it's great. Your colleagues know what to do. You can hand that over and say, switch namespace when you need a new context. It's nice. Dividing clusters up is easy. But then what about resilience? Like maybe cost is not your only concern, right? It's probably not. We like to test our changes. And in apps, we can do that in various different ways. But we also like to know that if we're going to upgrade our clusters, they're going to work afterwards. We want to know that the workload's going to work. So, starting from our ultra-simple architecture, maybe you have two clusters. And I'm going to pull out a pattern here. Treat clusters as cattle, not pets. So, I don't think this is a big surprise to people. But you can go cloud native with clusters. You can say, I've got one cluster most of the time, and then I'm going to surge. The same way that you can actually go that way. The same way that you can do that with a deployment. You can say, I've got 5 pods, and now I've got 6 pods, and I'm doing a rollout, and then I'm back to 5 pods. You can do that with clusters. And probably that's a pattern to adopt, because it's a cost-saving thing. If you're driven by cost, you don't want to be running 2 clusters all the time, just so that once in a while you can use the second one to upgrade. Anyway, so in this talk, I'm also going to talk about other concerns, and let's bring in isolation. So how about one cluster per environment? This is a pretty common pattern. So you've got a testing cluster, and you put test stuff in there, and you've got a production cluster. You can isolate these as well. So you don't just have to say, this is one context. So if you're on AWS, that's where we do our work, you'd put maybe testing in one AWS account, and you'd put production in a different AWS account. We're talking about isolation here. This pattern is also the one cluster pattern if you do all of your testing in production. And again, when you've done this, you can isolate on the sort of inner boundary of namespaces. So namespace per workload, I would say, is the starting point if your colleagues don't like to talk to each other. Namespace per component. So you could say, OK, we've got a back-end namespace in the production cluster, and we've got a data team namespace, and we've got a namespace for all of the different things. If you're doing microservices, you might have hundreds of namespaces. If you're using Kubernetes for something kind of simple, maybe you haven't. And I'm going to talk a little bit about the software as a services angle, because I get to see this a lot in my consulting work. So tenant is software as a services jargon for your customer. Like if you use Jira Cloud, the workspace in Jira Cloud that's got all of your team in it and all of your work, that's a SaaS tenancy. Some other company is a different tenant. And yeah, maybe don't do this. Maybe do use namespaces. I would say that the two technologies are obviously complementary. So I've talked about cost. I've talked about resilience. I've talked about isolation, security, isolation, whatever. You can do more than that. So yes, you might be worried that one customer shouldn't impact another. You might be worried that one team shouldn't affect another team's work. And you might be worried about money. But addressing all of those things doesn't cover all of the aspects that people are going to need to consider. Maybe you're wondering what I'm going to talk about next, but what I'm going to talk about is pace. So we like fast flow. We like things to be delivered quickly. We like the value to turn up. And we like the people working on the solution development to get it done quickly. Imagine for a moment that you have just one cluster, and everything I said about isolation isn't a big concern for your context. Your colleagues are skilled. They've gone and got those blue Cubestronaut jackets. They trust each other, but they still have to coordinate. And coordination work, I say, is the enemy of delivering at pace. So we don't want that to happen. We want to see our value delivered, and we want to see that teams can deliver value without having to talk to another team. And it's even worse if they have to talk to all the other teams. So if you haven't heard of team topologies, then you need to make sure that you watch Sarah Wells's talk earlier today on the recording, because she mentions it, and then go and do the thing that she says in that talk to go and read the book. But these are out of the team topologies books, these sort of shapes and diagrams and things. And if you've got that sort of one cluster, everyone's empowered to work on it, everyone's a cluster admin. And that means they all have to coordinate to see if anyone else is doing cluster admin work at just the wrong time. I'll give you a practical example. So who's heard of ingress? Okay, right, yeah. You should probably think about moving to Gateway, because upstream it's not really the way things are going, but it's what everyone uses, right? And ingress class is cluster scoped. So if you're working on an ingress solution and you're thinking, I'm going to change the cluster-wide configuration, well, now I have to coordinate. I cannot avoid, with this story, I cannot avoid having to do a little bit of a sync with the colleagues to make sure that I'm not breaking their use of ingress when I do my thing. And that's the problem. So you could be thinking, yeah, I'm going to solve this. I'm going to bring in a platform team. It helps, and if you've got lots of teams sharing a platform, it's quite good to abstract that away and say, right, we're going to form a team, a virtual team, of subject matter experts who look after our platform issues. But you still have to coordinate with them, and you have to ask the platform team if they're doing things, or the platform team has to ask every other team what's going on. And I said that the consideration we're thinking about is pace. Now, I'm guessing a lot of you are kind of way ahead of me, and you're thinking this. You're thinking, OK, that's the solution. We'll have a cluster per team. And I think this is a good solution for some contexts. I think it's worth considering. There's different ways to do it, and I'll talk about some of your options. The sort of straightforward way is to fire up your favorite infrastructure as code tool. That could be Terraform. It could be CDK if you're on AWS and you like CDK. Doesn't really matter, but you fire up a cluster per team. And if I visualize it, and I click the right button, it looks something like this. So let's say we've got a backend team, data analytics team, other app component teams, and also we've got some platform monitoring in there. Give them each a cluster, have some common patterns for how that's done, and allow each team to make its changes independently. They can do cluster upgrades, they can make cluster-wide changes. And crucially, I haven't really mentioned cluster extensibility, but your custom resource definitions, your API extension points, policies about nodes that have to be applied cluster-wide, all of these can land without teams having to talk to each other. And I'm not saying that this is going to produce fast flow any more than eating Special K turns you instantly into the athletes you see on the advert. But as part of a sort of calorie-controlled way of delivering, it's really helpful. And you can slice this a couple of ways. So you can have a namespace per environment. Yeah, that's clicking right. You can have as many clusters as you have teams, and then each team can slice their cluster up how they want to. So the team can say, well, we're going to slice our thing up with a namespace per environment, and another team can say, well, actually, we want production and then something else, maybe per developer. I'm going to come to that. Teams can work autonomously. But I'm going to come back to isolation because we haven't got these pure things. It's not just that we're dominated purely by cost, by resilience, by pace. We want to balance these things. And if you're in the position where these are on your horizon as conflicting aims that you have to address, you're probably thinking about them already. Anyway, I can only really put one word up on the slide because I've used a massive font. So one thing at a time, back to isolation. If isolation matters, yeah, you might want to do some different things. You could have a namespace per developer. You could say, yeah, we've got a cluster per team, and then each developer gets a namespace. Yeah, they can run Kubernetes on their laptop, and you can do that whether or not. Obviously, the number of clusters that you run now needs to have the number of developers' laptops that you have added to it. But you can do that. Having a cloud cluster is probably more useful, in my view, because it's for the slower feedback loop. Just as we heard in the last talk from Abby, and I've forgotten your name, Mauricio, right? Yeah. Having Kubernetes on your laptop it can feel a bit of an anti-pattern. But you get to a point where, yes, it's worked on your machine and you've gone for a good developer experience, and it's not working in integration. Let's give you a cluster so that you can figure things out and have that cluster look like the cloud and let you get unblocked on troubleshooting that without having to block the rest of the team's tests or whatever's going on. So we give you a namespace, we can give you a cluster per developer. What I'm talking about here is potentially going from one cluster per team to N clusters per team. Build a platform model where each team says, well, we're going to have a cluster or several. We'll figure out how to slice and dice it. Again, I think it's kind of about empowering teams to pick what works for them, giving them a platform definition to say, don't go too far from this paved path, but our paved path could be cluster per team. You can have more clusters. This is how you build them. It does have its challenges. I think the main one, and I haven't really come to this, I haven't really addressed this in this talk so far, is the overhead of managing all these clusters. Are we getting loads of people whose main contribution to value is solution development, coding in maybe TypeScript or Rust or PHP, whatever, and say, great, please continue to deliver all of that value, but we are also going to make all of your teams do Kubernetes cluster management. May not land as well, even if we tell them they don't have to run Kubernetes on their laptops. And these clusters, they're all going to need upgrading in this model. If each team runs its own Kubernetes cluster, each team's looking after its production upgrades. Maybe another team sort of comes in on a support basis. Maybe you bolt SRE onto the far end of this, but it still needs to be thought about. That's challenge one. Challenge two, we have limited our options for isolation. We're either not isolating as strongly as we can do. Go and watch Ian and Andy's talk for some of the risks of isolation. That's later today, this room. Or we're saying to teams, right, your solution developers, your skills are mainly elsewhere. Most of your contributions to value are much closer to the app. But would you mind making sure that you know how to isolate Kubernetes clusters with no security flaws as well? That'd be great. We probably don't want to do that. So this will all need managing. And the more clusters you have, the more that the cluster admin overhead matters. In a sense, the solution jumps out. I say that the solution jumps out. It is that you're providing, to kind of paraphrase Kelsey Hightower, a platform for building platforms as a service. You need to make sure that this load doesn't land on solution developers' heads. It's just, I don't think it's not fair, it's not going to scale well, it's not going to be cost effective. I'm just going to go back and talk a little bit about isolation, but there are solutions coming up. So you can go, if you do, just stick with the namespaces ideas. There's things you can do in Kubernetes. You can use controls at the cluster level and bake these into your paved path platform to say, actually, you don't get a namespace per environment, you get a namespace per environment per tenant where it's useful. So if you've got multi-tenancy, you've got banks maybe, or other customers that really feel they need to be kept apart, you keep them apart. And if you're not quite in the sort of finance sector, other places, and you don't need that much isolation, you can tier your tenants together. And so maybe this is all of the free tenants that are not paying anything for your platform, and you don't worry too much about resource contention, because if they're worried about it, would they give you some money, please? And then you've got your sort of medium tier, which is where you put most of your business. And then if you were running a SaaS thing or something internal that has a sort of software as a service quality to it, you can have a premium tier, and you can say, okay, each team needs to think about how it serves this tier especially, and we're going to do production readiness reviews, and we're going to do solution design, and make sure that the architecture serves the needs of your premium customers, but maybe there's only 7 of them, or 1. I've worked with quite a few customers where their top tier is this one firm that is the top of their target market, who pay them a large sum of money for a special service. If that's a business model, make it work. So, a few more isolation models. I've also not really talked about how you test your code. So let's talk about how you test your code. How about you have a cluster where you run your CI jobs, and then in that cluster, people make a namespace during the CI job, use the namespace to test things, and then tear that down again. That's pretty good. I think that's got something to say for it. You might find that your solution uses more than one namespace, because maybe you let teams choose their own ingress controllers, and they run the ingress controller in this namespace, and they run the solution in that namespace, and so you can't do this. And of course, there's a solution to that. You could do a cluster per pull request. So when you've got some code to review, you get a cluster built, you compile the code, you deploy the code to that cluster, you run all of your tests against that cluster, and then And then you pause it. And you say, OK, well, now I need a human in the loop because we get humans to check the code. Maybe the automation says, this doesn't need testing. It's a low-risk change. And eventually, you merge the code in. Let's not imagine when we close the thing and we regret our life choices. But we merge the code in, and we delete that cluster, and we think no more of it. Sounds good? Or does it sound like a lot of work? And so the next point that I'm going to bring in is toil. If you've not heard that, I will just run through the jargon for the benefit of people who've not come across it. Toil is kind of, I think Google came up with it for their SRE concept. Toil is the manual work that you do some of, but not too much. And if you are making a cluster per team, maybe that's OK, because you don't make teams very often. And if you've got a cluster per colleague, you might not be hiring colleagues very often. But if you're doing a cluster per pull request, you absolutely want to automate the thing. Teams that try this without automating platform operations, they don't enjoy the experience. And so there's a few things you can use. You can use vCluster. So that's from Loft, and you can learn about that by going to the stall, which is about there, physically, I think. Loft, I've got a stall as an exhibitor, so feel free to talk to them. They are literally here. They will be able to talk about it better than I can. It is not the only game in town. You could use Kamaji from Classix. That turns any Kubernetes cluster into a management cluster. It's not quite solving things the same way as vCluster, but in both cases, when you want to add another cluster because of a thing, you talk to the Kubernetes API server, and you sort of kubectl create tenant or kubectl create cluster, that kind of thing. Or, because you're automating this, you don't use kubectl. Maybe you write some Python or whatever. Please do automate it. Your operations people will love you for it. And so here's another pattern. Manage your clusters in code. I think I must have convinced the whole room here. I'd be surprised if anyone's feeling the opposite. It's all about being cloud native. I'm sure a lot of you can think that there's no other way you'd accept. I suppose this slide is for the rest of you, or both of you maybe. And maybe we call it something else. Sometimes we call this DevOps. Sometimes we call it platforms. We're talking about a platform for building platforms. And you need that cookie-cutter approach. And so if we've got Kubernetes anyway, I think building on that Kubernetes API, building on the paradigms of reconciliation and so on, really work well. Comes with challenges. So a specific challenge is that you may have some version constraints. You may find that you have to make sure that your nested clusters are not newer than your outer management cluster. Maybe the outer management cluster doesn't know about the potentially newer features, and you have to watch out for that. You might have brought back one of those synchronization points where you have to talk to every single team before you can complete your upgrades. And you can manage that risk. It's just something to think about. Bigger though, more abstractly, you get to build it. You can't buy this as necessarily a managed solution from anyone. You can get a lot of the bits for it, and you can absolutely pay people to make the job a lot easier. But you are now looking at integrations. You're now looking at owning more of those integrations. What's on offer, I think, is really good, but it adds non-zero complexity to your overall picture. If you only needed a few clusters, let's say 7 is the boundary. We like the number 7. If you were managing 7 or fewer clusters, I wouldn't go for Kamaji or vCluster or Capsule to manage namespaces. I think the complexity doesn't pay off. Whereas if you're managing 100 clusters, I think it's an obvious choice. Another challenge, you get to secure it. And to learn more about that, do go and see Ian Smart and Andy Martin's talk later this afternoon. They are experts in that particular aspect of compromising clusters. And you will learn things that I imagine you'll learn things that you didn't want to know about what's on you around securing your namespaces and clusters. And if you're using a tool to manage them, even if you've got a vendor-managed control plane, those inner clusters are kind of your responsibility. And there's only so much that you can shift away. I'm going to go back to cost. Very often, the right number of clusters isn't fixed over time. And I've talked for a whole bunch of reasons over why that is. It's really relevant to, I'll bring in the buzzword. Let's talk about AI/ML. So with ML, you might find that your inference is pretty efficient. You can do the inference part with a small cluster. It might even run on CPUs. And then you find that sometimes, just imagine that this case, AI/ML is often split into building a model, which takes an awful lot of GPU and clever computations, and then running the model, which is called inference. But maybe you've built the model. You throw the cluster away, you park it, and you're not tearing down a deployment or a stateful set or even a namespace. You could say that you're going to tear down a whole cluster. And so maybe this is the dream. Who knows? Thank you. That was my talk.